Going to see the next test, difference of two proportion test. First we saw single mean, second one single proportion, then third one difference of two means, now fourth one difference of two proportions, right? Test procedures, we'll see confidence interval and standard error. Difference of two proportion notations as usual: capital N, capital N2, N1, N2, population size small n1, small l2, sample size p1, p2, small p1, p2, sample proportion capital P1, P2, population proportion, and we know relation between q1 and p1, right? q1 equal to 1 minus p1 and q2 is equal to 1 minus p2 for both, right? Test procedure: step 1, to find the proportions. If n1 is the number of samples out of which x1 is favor of n, then small p1 equal to x1 by n1. Similarly for n2, so p2 is equal to x2 by n2. Then expected value of small p1 equal to capital P1 and expected value of small p2 is equal to capital P2. So variance of small p1 is equal to capital P1 capital Q1 by small n1. Variance of p2 is equal to capital P2 capital Q2 by small n2. To find the calculated value of z, right? So test statistics formula: z is equal to small p1 minus p2 minus expected value of p1 minus p2, small p1 minus p2 divided by root of variance of small p1 minus p2. That is equation number 1. Under the null hypothesis, h0 is p1 equal to p2. That is p1 capital P1 equal to expected value of p1, which is equal to p2, which is equal to small expected value of small p2. So expected value of p1 minus p2 is equal to expected value of p1 minus expected value of p2, which is equal to 0. So variance of p1 p2, which is equal to variance of p1 plus variance of p2, right? We know variance of a plus or minus ax plus or minus by, which is equal to a square variance of x plus b square variance of y. We are using that formula because x, if it is in the case of x and y are independent, right? So we know p1 capital P1 Q1 by n1 plus p2 Q2 by n2. So 1 implies test statistics z is equal to p1 minus p2 divided by root of p1 Q1 by n1 plus p2 Q2 by n2, right? This is first if the sample proportions are known, right? So test statistics z is equal to p1 minus p2 divided by root of pq by n1 plus pq by n2. The sample proportion are from the same population. First case, sample proportions are from different population. Then you will get p1 p2, right? Two population. Same population means p1 p2 all are equal to p we are taking, right? In the case of sample proportion small p1 p2 are given and population proportion p capital P is not given, then the formula is n1 small p1 plus n2 small p2 by n1 plus n2. To test statistics z is equal to capital P1 minus capital P2 divided by root of P1 Q1 by n1 plus P2 Q2 by n2. Population proportions are given. So in the case we need to test the sample proportions P1 P2, take the null hypothesis h0 is equal to p1 equal to p2. Alternate hypothesis p1 not equal to p2. Two-tailed test always you take that. Test statistics z is equal to p1 minus p2 minus capital P1 minus capital P2 divided by root of p1 q1 by n1 plus p2 q2 by n2. Sample proportion and population proportions are given, right? Test statistics in this case z is equal to p1 minus p2 minus p1 minus p2 divided by root of pq by n1 plus pq by n2. Here we are seeing all the test, right? All the test formula, right? Difference of two proportion type, right? So we have to take the formulas according to the given data. Note that, right? That is why we have clearly mentioned. So step by step 1 2 3 4 5 6, right? So if the sample proportion p1 p2 and the difference of population proportion are given, so you have to use this test statistics. In case of to find p, instead of they have given directly p1 minus p2 difference, but they don't have they given that P1 and P2 directly separately, then you have to find P using this formula. Step 2, defining hypothesis, that as usual the standard results table, right? Step 3, conclusion, same, right? Calculated value always less than tabulated value means null hypothesis accepted, otherwise rejected, right? Then confidence interval formula, small p1 minus p2 plus or minus z alpha root of p1 q1 by n1 plus p2 q2 by n2. Standard error, root of p1 q1 by n1 plus p2 q2 by n2. Thanks.